We're going to look at all 6 of these methods in the operator module. The first thing I want to do is from operator import star. The next thing that I want to do is I want to concatenate a string of data. So I can concat and then in parens A, B, C, D, E, F, both of them encapsulated within single quotes, delimited with a comma, and I get A, B, C, D, E, F. Good question to ask is, does this work with lists? Well, here are 2 lists. I'm going to feed them both to concat. Let's see what we get. We get 1, 2, 3, 4, 5, 6. So it works with string and with lists. The next thing that I want to do is key in x equals George boole. After that, I'd like to key in y equals George. Now, I want to see if y is in x. So I key in contains x, whatever's in y, and the answer is true. Next, I want to key in z equals Sam. Once again, I'm going to key in the contains function, but I'm going to say z in x. I should get false, and I do. All right, let's move on to the next one. Let's assign some variables of value. A equals 2 and B equals 3. If I now do floor division, F-L-O-O-R-D-I-V, I'm going to divide A by B. And it's going to round it off to a 0. But if I do true division of A divided by B, I'm going to get 0.6666, etc., etc., because 2 divided by 3 gives me that. Now, in the next one, we're going to do the XOR gate, the XOR function. So, A is equal to 1, and B is equal to 0. Now, if you take the XOR function and feed it 2 values, you're going to get a true or a false back from it based on this. You'll get a true, but only if one of these values exclusively is a 1. This one or this one exclusively has to have a 1 in it, has to have a 1 in it in order to get back true. So I hit enter and I get 1. Now let's change that. Now I'll key in A equals 0 and B equals 0. I'll run this again and I'll get back a false, a 0. Because neither of them exclusively was a 0. Well, what if both of them were 1s? What happens then? Well then, let's find out. The rule says that just one exclusively, or the other one, has to have a 1 in it. But here, both of them have a 1 in it. I think we're going to get back a 0. And we do. Here is an XOR gate in electronics. I'm going to put 2 switches here and an LED. Move this over. Line it up fairly nice. Connect them all. This is an XOR gate. Now it's connected up. Let's run this. And now there are 2 zeros on the input of this XOR. So you get a 0. Now I'm going to put a 1 exclusively on this input. It lights up. Shut this off. I'll put a 1 exclusively on this input. 0 on the other. I get a 1 output. But if I put both of them on, this is not an exclusive 1 on the inputs anymore. This goes to 0. and the light goes off. This is the programmatic equivalent of that XOR circuit that we just saw. We have one more that we want to cover, and that's the invert method. Let's say I run the invert function on the number 9. What is the system going to do? Well, simply put, the system will take the number 9, add a 1 to it, come up with the number 10, and basically put a negative sign in front of that. In other words, it's like, here's 9, and it goes down to the dividing line, 0, and it goes all the way to negative 9, and then 1 more to negative 10. But of course, it's easier to think of it in just this manner. 9, add 1 to it, put a negative sign in front of the answer, and there's your inversion. Let's see if that works. Invert 9, and I get negative 10. What do you know? Let's try another one. Invert 3. Now I add 1 to 3. I get 4. Put a negative sign in front of that. I get negative 4. And that's what we get. So we just looked at 6 more methods out of the module in Python called operator. This is George Boole. I hope this was helpful to you, and good luck.